Part 1. The Cosmic Messenger. Picture this. It's 2024, and somewhere in the vast cosmic ocean that surrounds us, NASA's most sophisticated instruments pick up something unusual, something that defies easy explanation, and then silence. The kind of silence that makes you wonder what they actually saw. Let me tell you something about space that keeps astronomers up at night. We're not looking at some static, peaceful void. We're looking at a cosmic shooting gallery. Objects are constantly streaming through our solar system. Most of them we detect. Some of them we miss. And some of them, apparently, we see very clearly but don't immediately talk about. Think about that for a moment. We've built telescopes that can see galaxies billions of light years away. We've sent rovers to Mars that operate for years. We've touched the moon. We've placed spacecraft at the very edge of our solar system, still communicating with Earth from incomprehensible distances. We've achieved technological feats that would have seemed like pure magic to our ancestors. Yet there are still things moving through our cosmic neighborhood that surprise us. Things that catch us off guard. Things that make scientists pause and think very carefully about what they're looking at. In December 2017, something happened that would change everything. Scientists observed an object unlike anything ever documented before. An object that didn't fit into existing categories. An object that seemed to challenge our understanding of the universe itself. They called it Oumuamua. That's a Hawaiian word meaning scout or messenger from afar. The name was chosen deliberately, a sign of respect and wonder toward what might be humanity's first confirmed visitor from beyond our solar system. This object came screaming through our solar system at speeds that could only suggest one thing. It originated from interstellar space, from somewhere far beyond, from another star system perhaps light years away. It had traveled across the void between stars, a distance so vast it defies human comprehension, and passed through our cosmic neighborhood at the precise moment humans had developed technology to see it. Let that sink in. For the first time in human history, we definitively detected something from outside our solar system. Not theoretically, not mathematically, observationally, visually, undeniably real. We pointed our telescopes at the sky and saw something that proved beyond doubt that the universe is far busier than we imagined. When Oumuamua first appeared, the astronomical community reacted with excitement and bewilderment. This was unprecedented. Here was an object that didn't fit any existing category. It wasn't like known asteroids. It wasn't like familiar comets. It was something new, something foreign, something that had traveled across the incomprehensible gulf between stars to arrive at our doorstep. The numbers were staggering. Oumuamua moved at approximately 26 kilometers per second relative to the sun. That velocity screamed one thing to everyone examining the data. This object came from elsewhere. It didn't form in our solar system. It didn't originate from the dust cloud that birthed our sun. It was a traveler, a visitor from the deep cosmos. That speed is crucial. When objects form within a solar system, they inherit its velocity. But Oumuamua had excess velocity. It was moving faster than the sun's gravity alone should allow. That excess is the signature of interstellar origin. It's the proof that this object came from beyond. Scientists calculated its trajectory backward through time and space. Where did it come from? What star system ejected it? What planetary formation launched it across the stars? The calculations revealed Oumuamua had been traveling for millions of years, drifting through darkness, untouched by any star or planet, until it arrived at our solar system just as humans developed the capability to see it. Some might call that coincidence. In cosmic terms, it might be inevitable that eventually a species develops the technology to witness arrivals like this. But here's where it gets truly puzzling. Oumuamua wasn't behaving like it should. Its trajectory showed anomalies, subtle deviations from what gravity alone should produce. Its brightness fluctuated in ways suggesting an unusual shape. The pattern indicated something cigar-shaped, something needle-like. Scientists estimated an aspect ratio of approximately 10:1. An object roughly 400 meters long but only 40 meters wide. Imagine a cosmic cigar hurtling through space at 26 kilometers per second. That's what the observations suggested. And then there were trajectory anomalies, deviations from the expected path. Scientists proposed these might result from outgassing, jets of material venting from the object like a comet approaching the sun. That would be natural. Comets show this behavior constantly. Jets of vapor escape and produce a rocket effect altering trajectory slightly. It's observable. It's explainable. But other scientists, serious researchers from Harvard, the University of Pennsylvania, legitimate institutions, suggested something more provocative. What if the anomalies weren't random fluctuations from natural processes? What if they were too precise, too controlled, too deliberate? What if it was artificial? Now, I want to be absolutely clear. These weren't crackpots. These weren't fringe researchers. These were serious scientists saying, "We must consider this possibility." They published papers. They presented at conferences. They said the evidence doesn't rule out an artificial origin. That's what science is supposed to do. Follow evidence wherever it leads. Challenge existing paradigms. Ask hard questions. But here's the problem. By the time scientists fully analyzed Oumuamua, it was disappearing into space. We couldn't send spacecraft to intercept it. Technology doesn't exist for that. We couldn't maneuver telescopes for closer observation. Oumuamua was too fast, too distant. We could only watch it recede, taking secrets with it. It was like seeing a ghost at the edge of vision. When you turn to look directly, it's gone. But it left something behind. It left undeniable proof. Interstellar objects are real. They're traveling through our solar system. They exist as observable phenomena in our cosmic neighborhood. That was a paradigm shift, a fundamental change in our understanding. Part 2. The universe reveals itself. Fast forward to 2024. The astronomical community is no longer surprised by interstellar objects. We've adjusted models, created designation systems, built frameworks. We have categories for these visitors. The discovery of Oumuamua forced us to think about how many such objects might exist, how often they pass through solar systems, what the probability was of detecting them. And when we asked these questions, we realized something profound. These objects might be far more common than assumed. Early models suggested thousands could pass through our solar system at any given time. Thousands. We only detected one because we hadn't been looking. But once we knew they existed, once we adjusted search parameters, once we told our telescopes to look for these objects, we started finding them. Now NASA, along with international space agencies, actively monitors them. They're watching space lanes like harbor masters watching shipping routes. Because they know visitors come. They know objects from distant star systems pass through. They want to understand what's happening. They want data. They want to learn about the cosmos. Sometimes visitors arrive with detection far away. Sometimes we detect them as they're passing through. But they arrive, and we're learning to see them. And then another one shows up. An object designated 3I/Atlas. That designation is profoundly significant. The I stands for interstellar. We're not figuring out where it came from. We know it came from interstellar space. Interstellar is now standard category. We're no longer observing just one of these objects. We're cataloging them, creating nomenclature, building a new astronomy branch around objects from other star systems. That's how much Oumuamua changed understanding. 3I/Atlas travels through our cosmic neighborhood, and NASA's detection systems watch. These are the most sensitive instruments ever built. Telescopes that detect photons traveling billions of years. Systems that sense heat signatures miles away in cold vacuum. Equipment designed specifically to see the universe in ways human eyes cannot. These instruments scan the sky constantly, collecting data, analyzing light, detecting radiation, looking for anything unusual. And then something happens. Near 3I/Atlas's trajectory, NASA records an observation. An anomaly, something unexpected, something not fitting existing models, something worthy of scientists' attention, something that matters. Except information doesn't flow freely. There's no cascade of press releases. No immediate peer-reviewed publication. No Twitter announcements from NASA spokespersons. Instead, restraint, caution, careful analysis before public statements. The information isn't suppressed exactly, but it's not flowing freely either. Think about what that means in our current age. We live in instant communication, an age of social media, an era where discoveries get celebrated within hours, a time when citizen scientists access the same data professionals use, an age of transparency and real-time analysis. Yet NASA encounters something mysterious and chooses restraint. That itself is the story. Part 3. Understanding the silence. Let me be absolutely clear about something. I'm not here to peddle conspiracy theories. I'm not here to suggest alien spacecraft are piloting asteroids through our solar system. That's not how science works. I believe in evidence. I believe in peer review. I believe in observation and testing. I believe in reproducibility. But I acknowledge something profound that evidence demands. We live in a time when the universe reveals itself as far stranger, far more populated, far more active than ancestors imagined. Consider statistical reality. Think about what we know about the universe now that we didn't know 20 years ago. How much understanding has evolved in just 2 decades? We know with certainty that exoplanets, worlds orbiting distant stars, are incredibly common. Surveys suggest exoplanets outnumber stars in our galaxy. Let that sink in. More planets than stars. Billions upon billions of worlds, each potentially different, each potentially unique. Many are potentially habitable. We've developed classification systems. We look at planetary size and orbital distance and estimate whether liquid water could exist. We assess atmosphere possibilities. We calculate habitable zones. What we've discovered is shocking. Planets similar to Earth, orbiting in habitable zones where liquid water could exist, are commonplace throughout the galaxy. They're not rare. They're not unusual. They're everywhere. In our Milky Way alone, billions of Earth-like planets could exist. Billions. Think about that number. Billions of planets that could potentially support life. That's not speculation. That's observational data. That's based on exoplanet surveys. That's the result of careful astronomical study. We know life emerged on Earth roughly as soon as conditions allowed. Fossil records show this. Geological evidence supports it. Life appeared in our oceans within perhaps 300 to 400 million years after the planet stabilized. Earth formed 4.5 billion years ago. Life appeared almost immediately. It didn't take billions of years. It took hundreds of millions at most. This tells us something important. Life isn't rare. It's not some miracle. It's not an improbable accident. Life is a natural consequence of chemistry and physics and time. Given right conditions, life emerges. We know the universe is roughly 13.8 billion years old. That's incomprehensibly vast. An amount of time difficult for human minds to grasp. We can say the number, but understanding the immensity is nearly impossible. But think about what happens in that time. Countless solar systems form. Countless planets emerge. Countless conditions suitable for life arise. On many planets, life would have emerged. Evolution would have happened. Species would have diversified. On some worlds, intelligence would have evolved. On some worlds with intelligence, technology would have developed. On some worlds with technology, spacecraft would have been built. Probes would have been launched. Visitors would have been sent to explore. Think about human history. We emerged roughly 200,000 years ago. We developed agriculture 12,000 years ago. Writing emerged 5,000 years ago. The scientific method emerged 400 years ago. Yet in just 70 years, we went from having no spacecraft to having robots on Mars, probes leaving the solar system, and telescopes seeing the universe's beginning. Imagine a civilization with even a 10,000-year head start. Imagine a species developing technology 1,000,000 years before us. Imagine a civilization sending probes to explore distant systems for the past 100 million years. They'd be incomprehensibly advanced. Their technology would seem like magic. Their capabilities would be beyond comprehension. There would probably be billions of such civilizations in the galaxy at different development stages. Some just emerging, some millions of years old, some extinct, some still exploring, some turned inward, some turned outward. In that context, believing Earth is the only intelligent world, that we're the only technological civilization in the galaxy, becomes statistically absurd. It becomes vanishingly improbable. It becomes almost incomprehensible that we would be alone. The fact that Oumuamua arrived with motion anomalies, that matters. We've known theoretically for decades that objects could travel between star systems. Physics has always been sound. We've known an object with right velocity in right direction could escape one system and travel to another. Interstellar travel is possible. It violates no physics laws, but observing it, actually seeing it, detecting an object from another star system, that changes everything. It transforms theoretical into actual. It means the galaxy isn't as empty as it feels looking up at night. We might be a busier neighborhood than realized. The universe isn't quiet and isolated. We're part of a vast, active cosmos full of phenomena we're beginning to understand. And in 2024, there's another one, 3I/Atlas. And NASA saw something worth investigating, something that apparently warrants discretion before public announcement. Part 4. What we've learned. Think about what we've learned from Oumuamua that applies to 3I/Atlas. When Oumuamua was first discovered, astronomers had no catalog of what normal interstellar objects look like.
No baseline.
No comparison. One example, one data point. When Oumuamua exhibited anomalies, we couldn't definitively say whether they were unusual or expected. We couldn't say whether they were normal for interstellar objects or indicated something extraordinary. We were building frameworks as we went. But now we have more data. Now we have observations. When 3I/Atlas appears with seemingly anomalous characteristics or behaviors, scientists can actually compare them. They can analyze data in context of what we learned from Oumuamua and other detected interstellar objects. They can ask meaningful questions. Is this behavior consistent with Oumuamua? Is it consistent with natural interstellar object models? Is it within expected ranges from outgassing or other natural processes? Or is it something different, something unexpected, something requiring new explanation? The fact that NASA exercises caution suggests they take these questions seriously. They're not jumping to conclusions. They're not making announcements without evidence. They're not claiming discovery with ambiguous data. They're doing what good science demands, carefully examining data, considering multiple explanations, ruling out obvious before considering extraordinary, and preparing announcements only when achieving sufficient certainty. That's not conspiracy. That's not cover-up in nefarious sense. That's the scientific method functioning as it should. Here's what fascinates me about this moment in human history. We've reached a threshold where the universe becomes real to us in unprecedented ways. Not as mathematics, not as philosophy, not as ancient mythology, but as observation, as data, as phenomena requiring explanation. For most of history, the cosmos was something we wondered about, something we could only imagine. We created myths and religions explaining stars. We told stories about gods and cosmic forces. The universe was mystery. We barely reached the moon. We only dreamed about stars. Then came scientific revolution. We developed mathematics describing celestial motion. We created telescopes extending our reach. We began understanding the universe through observation. We began seeing it as governed by natural laws, something comprehensible, something understandable through reason and evidence. Then came technology, spacecraft, satellites, probes. We sent robots to other worlds. We walked the moon. We launched space telescopes seeing deeper and clearer than Earth-based instruments. Now we're at the point where we're not just observing the universe passively. We're actively searching for it. We're looking for life, looking for intelligence, looking for signs of technology from other worlds. We're not speculating about whether life might exist elsewhere. We're asking about distribution. We're asking how common it is. We're asking about forms it might take. We're not wondering whether interstellar travel is possible. We're detecting objects that might be doing it. Is that what we're looking at with Oumuamua or 3i/Atlas? Is it artificial visitors from another world? Is it technology sent from another civilization? I don't know. Evidence doesn't conclusively point that direction. But evidence doesn't rule it out either. That's precisely why NASA is careful. That's precisely why the proper response is caution and rigorous analysis. Part 5. Paradigm shifts in science. Here's something else crucial to consider. Our understanding of the universe has been wrong before, repeatedly, spectacularly. Humans once believed Earth was the universe's center. That understanding persisted for thousands of years, embedded in culture, religion, cosmology. We built elaborate planetary motion models assuming Earth was central. Philosophers and theologians insisted on it. It seemed obvious. Earth was beneath our feet. We were clearly central. Then evidence forced revision. Copernicus, Galileo, Newton. Data accumulated. Observations piled up. It became undeniable. Earth orbits the sun. We're not special that way. We're one planet among others, orbiting an ordinary star. That was painful for human culture. That realization displaced us from our special position. But it was true. Evidence demanded it. We accepted it. We once believed the sun was the universe's center. Everything revolved around it. The sun was ultimate. Everything orbited it. Then we discovered other galaxies. Billions of them. Islands of stars scattered throughout space. Our sun became a minor star in a minor galaxy. We're not special that way either. We once believed the universe was static and eternal, unchanging, existing always. Then we discovered it was expanding. Edwin Hubble made that discovery in the 1920s. The universe expands. Galaxies move away from each other. The universe evolves. It has history. It wasn't eternal. It had a beginning, the Big Bang. Then we discovered expansion was accelerating. The universe doesn't just expand. It expands faster and faster. Expansion is driven by something we don't fully understand. We call it dark energy. The universe is stranger than we thought, more dynamic, more mysterious, and that pattern continues. Every time we look deeper, every time we build better instruments, every time we gather more data, every time we push observational boundaries, we discover the universe is stranger and more complex than previous models suggested. So when we encounter objects like Oumuamua or 3i/Atlas that don't fit our existing categories, that's not violation of understanding. That's an invitation to expand understanding. That's the universe telling us we still have more to learn. That's the cosmos reminding us that our knowledge is incomplete. That's reality saying, you don't know everything yet. Keep looking. Keep wondering. Keep asking questions. Part 6. Why the silence tells us something. Let me talk about why NASA's silence is actually informative. It reveals something important about how science actually operates. In popular imagination, science works like a machine. You observe something. You immediately announce it. You publish. The world learns. News spreads. Understanding expands. But that's not how it works, especially when something significant is at stake. In reality, NASA operates under intense scrutiny. Every statement they make is analyzed by journalists, scientists, skeptics, believers, everyone. Every announcement is dissected. Every claim is questioned. There are protocols for discovery announcements. There are careful procedures for verifying information before public statements. There are consequences for premature claims or false announcements. If you claim discovery and you're wrong, you damage credibility. You damage your institution's credibility. You give ammunition to people claiming science doesn't work. You undermine public trust. So when NASA encounters something unusual and doesn't immediately release information, that tells us something important. It tells us they take it seriously enough to verify thoroughly. It tells us they're not confident enough in initial interpretation to make public statements. It tells us they're gathering more data, running analyses, considering alternative explanations, asking hard questions. They're doing science. And in the age of social media and instant communication, that restraint is itself remarkable. In a world where leaks are common, where confidentiality is difficult, where rumors spread faster than truth, where someone could post observations on Twitter reaching millions instantly, the fact that NASA maintains operational security around their observations suggests they're being very careful. There are legitimate scientific reasons for this caution. There are good reasons for this restraint. False positives happen. You observe something. Initially, it looks anomalous, unusual, but as you gather more data, you realize you misunderstood. You made analytical errors. You misinterpreted observations. What seemed anomalous becomes consistent with existing models. It happens constantly in science. It's part of the process. Instrumental artifacts are real. Your instruments produce false signals. Data contains errors. Software has bugs. Equipment needs calibration. You must check everything carefully. Run tests. Verify that what you're seeing is real, not instrumental error or noise. You must consider all possible explanations before settling on one. Science requires considering the simplest explanation first. The explanation requiring fewest assumptions. The explanation most consistent with what we already know. You rule those out before considering exotic possibilities. So when NASA observes something near 3I/Atlas, they probably follow systematic process. First, they verify the observation is real. They check instruments, run calibration tests, ensure they're seeing what they think. Second, they consider natural explanations. Could this be outgassing? Could this be a small moon? Could this be dust or debris? Could this be gravitational effects? They explore conventional possibilities. Only after ruling out the obvious do they consider more exotic options. That takes time. That takes careful analysis. That takes collaboration and peer review. During that time, there's relative silence. No announcements. No press releases. No public statements. Just scientists doing science. Just researchers gathering data and thinking carefully about what it means. Part 7. The realization that we're not alone. This is the moment in human history where we're realizing we're not alone in the universe. Not in the sense of harboring life on Earth, we've always known that. We're surrounded by billions of living organisms. But we're realizing we're not alone in the cosmos. We're realizing that life, intelligence, technology, civilization, these aren't unique to Earth. They're part of the universe's fabric. And that realization is happening not through speculation or philosophy or ancient texts. It's happening through observation, through data, through patient, methodical work of astronomers and physicists pointing humanity's eyes toward the stars and finally, after thousands of years of wondering, starting to see what's actually out there. Oumuamua was the first step, the first definitive observation of an object from interstellar space. It was proof that the universe is far more active than imagined. It was the opening of a new field of study. 3I/Atlas is the second step. There will be more. There will be a continuous stream of discoveries as detection capabilities improve, as telescopes become more sensitive, as computers become more powerful. As instruments improve, we'll detect more interstellar objects. We'll find ones closer. We'll find ones larger. We'll find ones more anomalous. With each discovery, we'll learn more about what's traveling through our cosmic neighborhood. We'll build better models. We'll develop better understanding. We'll refine our categories. We'll adjust our assumptions. We'll evolve our science. The universe has always had more stories to tell than we've been prepared to listen to. For thousands of years, we looked up at the sky and wondered. We asked questions about the cosmos's nature. We created stories and myths explaining what we saw. We engaged in philosophy and theology trying to understand our place. Oumuamua told us that our wondering wasn't foolish, that the universe is indeed populated with strange and exotic objects, that visitors do arrive from beyond. 3I/Atlas is telling us that, and the silence we're hearing from NASA might not be the absence of news. It might be the sound of science taking a deep breath before saying something that changes everything. Part 8. When the announcement comes, Think about what happens when NASA finally makes an announcement about whatever they observed. Think about what that announcement will mean. If it's a natural object, that's interesting but not revolutionary. We'd learn about interstellar object properties. We'd refine our models. That's valuable science. But it doesn't change everything. If it's something anomalous, something requiring new explanation, that opens new research avenues. It expands understanding. It suggests phenomena we don't yet understand. That's more significant. That's science pushing knowledge boundaries. If it's something that genuinely appears artificial, something that genuinely appears to be a probe or spacecraft from another civilization, something showing signs of engineering or design, well, that's the most profound announcement in human history. That's the moment we definitively learn we're not alone. That's the moment the universe stops being abstract and becomes immediate. That's everything changing in one instant. We live in an era where the cosmos is beginning to reveal its true nature. Not through speculation or fantasy, but through observation, through data, through the patient, methodical work of scientists devoted to understanding the universe. We're at a threshold. We're at a moment where the universe stops being something we read about in textbooks and becomes something we interact with. Something that affects us. Something forcing us to reconsider everything we thought we knew about existence. The question isn't whether something unusual is happening in our solar system. The question is what we do with that knowledge when it becomes undeniable. That's what NASA is contemplating. That's the calculation they're making. That's silence worth waiting for. Because when it breaks, the universe stops being a distant abstraction and becomes something far more immediate. It becomes our neighborhood. It becomes real in a way it never was before. We finally understand what neighborhood we actually live in. Whatever NASA saw near 3I/Atlas, they saw something real. Something demanding investigation. Something worth more than silence, but also worth more than hasty proclamation. That balance, that is the cutting edge of science in 2024. And if there's one thing we can absolutely promise, the universe isn't finished surprising us yet. We are living in the most interesting time in human history to be looking up at the sky. We have the tools. We have the knowledge. We have the capability to detect objects from other star systems. We have the framework to begin asking meaningful questions about what's out there. And the answers are starting to arrive. The age of wondering is giving way to the age of knowing. And the universe, as always, is far more interesting than any story we could have invented. The universe has always had more stories to tell than we've been prepared to listen to. Now we're finally listening. Now we're finally ready to hear what the cosmos has been trying to tell us all along. And in that moment, everything changes. Part 9. The deeper implications. But let's go deeper into what the discovery of 3I/Atlas and NASA's careful response really means for our understanding of the cosmos. It's not just about one object or even a handful of interstellar visitors. It's about what these objects represent in the grand scheme of cosmic evolution and the prevalence of technology throughout the galaxy. Think about the Fermi paradox for a moment. It's one of the most profound questions in science. In the 1950s, physicist Enrico Fermi sat down and calculated the numbers. Given the vast number of stars in our galaxy, given the age of the universe, given what we know about the likelihood of life emerging, there should be thousands, perhaps millions of intelligent civilizations in our galaxy alone.
Millions.
And yet, we see no clear signs of them. We detect no radio signals. We observe no megastructures. We find no evidence of their presence anywhere in the cosmos. Fermi looked at these numbers and asked the famous question, where is everybody? That question has haunted scientists for decades. How can the numbers suggest such a crowded galaxy when our observations suggest we're alone? This contradiction became known as the Fermi paradox. And it's one of the most interesting puzzles in science because it forces us to confront the possibility that either our calculations are wrong, or our assumptions about life and intelligence are wrong, or something else is going on that we don't yet understand. But what if the answer to the Fermi paradox isn't that civilizations don't exist? What if the answer is that we simply haven't been looking the right way? What if the universe is actually full of civilizations, but they operate in ways we haven't been prepared to detect? Consider this, we've been looking for radio signals. We've been scanning the skies with the SETI program, the search for extraterrestrial intelligence, listening for radio transmissions that would indicate an advanced civilization trying to communicate. But radio signals are actually a very recent technology from a cosmic perspective. Humanity has been transmitting radio signals for only about 100 years. Before that, we had no way to broadcast across the stars. So we're essentially listening for a technology that's roughly 100 years old, broadcast by a species that's only been able to do so for a blip in cosmic time. We're looking for signals from civilizations that might be millions or billions of years ahead of us. It's like an ant listening for human speech. It's like a bacterium trying to detect a symphony. The scales don't match. The technologies don't align. But physical probes? Spacecraft? Interstellar vessels? Those are technologies that could persist across millions of years. Those are artifacts that could be detected through observation. Those are signs that a civilization could leave behind that would remain findable across cosmic timescales. So what if Oumuamua and 3I/Atlas and other interstellar objects we're beginning to detect aren't random cosmic debris? What if they're intentional probes sent by civilizations exploring their galaxy? What if they're automated spacecraft launched millions of years ago that are still traveling through space, gathering data, sending information back to their creators? That would be a completely different answer to the Fermi paradox. That would explain why we don't detect radio signals. Intelligent civilizations might have moved beyond such primitive communication methods. They might have advanced to technologies we can barely imagine. They might be communicating through means we don't even recognize as communication. But they would still send probes. They would still explore. They would still launch spacecraft to investigate distant star systems. And if they were sophisticated enough, if they were ancient enough, if they had been doing this for long enough, then probes from multiple civilizations could be constantly streaming through our galaxy, passing through solar systems, occasionally being detected by species just primitive enough to develop detection technology but not advanced enough to understand what they're looking at. That's a profound possibility. That's worth thinking about. NASA's silence about 3I/Atlas makes more sense in this context. If they detected something that could potentially be an artificial probe, something with characteristics suggesting intentional design, something that doesn't fit natural explanations, then the implications are staggering. You can't just announce something like that casually. You can't tweet about it. You can't hold a press conference without being absolutely certain of what you're looking at. Because once you say those words, once you say, "We have detected evidence of extraterrestrial technology," everything changes. Every government will be involved. Every religious institution will respond. Every news organization will cover it 24 hours a day. The stock markets will react. International relations will shift. The entire human species would be forced to confront the reality that we are not alone, that intelligence exists elsewhere, that we are one civilization among many. That's not something you announce until you are completely certain. That's not something you can take back. Once those words are spoken, humanity crosses a threshold from which it cannot return. Part 10. Implications for human civilization. Think about what contact with evidence of extraterrestrial intelligence would mean for human civilization. Throughout our history, we've encountered other human cultures. And those encounters have always been transformative, often traumatic. When Europeans arrived in the Americas, the civilizations they encountered were fundamentally changed. The same happened with colonialism in Africa and Asia. Contact between distant human civilizations has always altered the course of history. But that's contact between humans, between species that evolved on the same planet, that share the same basic biology, that are fundamentally similar in their needs and desires. Contact with evidence of extraterrestrial intelligence would be far more profound. These wouldn't be creatures like us. They'd have evolved in an entirely different environment. They'd have entirely different biology. They might not even be biological at all. They might be artificial intelligences. They might be collective consciousnesses. They might be forms of life that Earth biology has never contemplated. And the fact that they achieved space travel, that they achieved the capability to send probes across interstellar distances, means they're at least as advanced as us, probably far more advanced. We'd be the ones encountering the more powerful civilization. We'd be the ones facing potential exposure to technology and knowledge beyond our comprehension. That's a humbling thought. Throughout human history, we've gotten used to being at the top of our food chain. We've gotten used to being the most intelligent species on our planet. We've gotten used to being in control. The discovery that we're not the most advanced intelligence in the galaxy, that there are others out there who are older, more experienced, more technologically sophisticated, that's a fundamental shift in how we understand ourselves. And yet, it might be necessary. It might be exactly what humanity needs at this point in our development. We've reached a stage where we're capable of destroying ourselves. We have nuclear weapons. We have biological weapons. We're changing our climate. We're degrading our environment. We're facing existential risks from our own technology. Perhaps the discovery that we're not alone, that other civilizations exist and have presumably overcome the challenges we're facing, might inspire us to be better, might inspire us to work together, might inspire us to solve our problems before they destroy us. Or perhaps it might destabilize us. Perhaps it might create fear. Perhaps some would see it as a threat. History suggests that when humans encounter more advanced civilizations, the results aren't always positive for the less advanced civilization. But that's a problem for another time. Right now, the question is simply, are we actually seeing evidence of extraterrestrial technology? And that's the question NASA is carefully considering. Part 11. The Science of Detection. Let me talk about the actual mechanics of how NASA would detect something artificial versus something natural. What characteristics would distinguish a probe from a natural object? First, there's the trajectory issue. Natural objects follow predictable paths based on gravity alone. They don't have reasons to maneuver. They don't have reasons to change course. They follow ballistic trajectories. If an object deviates from a ballistic trajectory in ways that can't be explained by outgassing or other natural forces, that suggests artificial propulsion. That suggests something is actively controlling its path. Second, there's the question of shape and structure. Natural asteroids are often irregular, shaped by collisions and gravitational interactions. They're lumpy, they're chaotic, they lack symmetry. But if an object has too much symmetry, if it's too regular, if its shape is too obviously optimized for a purpose, that suggests design. That suggests engineering. Third, there's the question of composition and material. We can analyze light reflected from objects and determine what they're made of. If an object reflects light in ways that suggest artificial materials, if the composition is too uniform, if the elements are arranged in patterns that don't occur naturally, that's another sign of design. Fourth, there's the question of electromagnetic emissions. If an object is emitting radio waves or other electromagnetic radiation in patterns that suggest communication or processing, that's a huge indicator of artificial origin. Natural objects don't transmit. They don't process information. They don't compute. So there are multiple ways to distinguish artificial from natural. And NASA has instruments that can perform all these analyses. They have spectroscopic equipment. They have electromagnetic sensors. They have sophisticated analysis capabilities. So when they observe something near 3I/Atlas, they can run these tests. They can gather data. They can ask meaningful questions. And if the answers point toward artificial origin, they'd need to be absolutely certain before announcing anything. Part 12. What happens next? So what happens when NASA finally makes their announcement? What will the discovery of artificial interstellar probes mean for human civilization? First, it would validate decades of scientific inquiry. The question of whether we're alone has been central to science since the invention of the telescope. The answer, if it comes, would be one of humanity's greatest discoveries. Second, it would immediately spawn a new field of study. Scientists would want to know everything about these probes. Where do they come from? What are they designed to do? How old are they? Are they still functioning? Can we communicate with them? Can we learn anything from their technology? Third, it would force a complete reevaluation of our place in the cosmos. We'd have to accept that we're not special. We'd have to accept that intelligence is common. We'd have to accept that other species have achieved what we've only recently achieved, and probably far exceeded it. Fourth, it would raise profound questions about humanity's future. If other civilizations exist and are sending probes, what's their ultimate goal? Are they exploring peacefully? Are they scouting for resources? Are they looking for potential threats? What do they want? These are not easy questions. These are questions that philosophers and theologians and scientists and politicians would debate for centuries. But they're questions we might have to answer sooner rather than later. Part 13. The Cosmic Perspective. Carl Sagan once said something that I think is profoundly relevant here. He said, "The cosmos is a pretty big place. If it's just us, seems like an awful waste of space." That statement captures something essential about the way we should think about the universe. We live in an incomprehensibly vast cosmos. There are more stars in the universe than there are grains of sand on all of Earth's beaches. More galaxies than there are stars visible to the naked eye. More planets than we could possibly count. In the face of that vastness, the idea that Earth is the only place where intelligence emerged, the only place where technology developed, the only place where beings gaze up at the night sky and wonder, that seems statistically absurd. That seems like a cosmic waste. That seems almost deliberately unlikely. And yet, for all of human history, that's been our working assumption. We've assumed we're alone. We've built our religions and our philosophies and our entire understanding of existence around the idea that we're the only intelligent beings in the cosmos. The discovery of Oumuamua started to change that. It provided the first concrete evidence that objects from other star systems can reach us. The observation of 3I/Atlas continues that process. And if NASA detects something that appears artificial, something that appears to be a probe from another civilization, then we cross a threshold that humanity has never crossed before. We become a species that knows with certainty that we're not alone. And that knowledge, that realization, that understanding will reshape human civilization in ways we can barely imagine. It will change our art, our science, our religion, our philosophy, our culture, our politics. Everything will be filtered through the lens of this new knowledge. Everything will be interpreted in light of the fact that other intelligences exist. Part 14. The Future of Exploration. Once we confirm the existence of artificial interstellar probes, the next step would be to understand them. We'd want to know everything about them. We'd want to retrieve them if possible. We'd want to study them. We'd want to reverse engineer them if we could. And that would launch humanity into a new era of scientific advancement. If we could understand even a fraction of the technology that an ancient interstellar probe possessed, we could advance our own technological capabilities by centuries or millennia. We could solve problems that currently seem unsolvable. We could develop propulsion systems that would let us reach the stars ourselves. That would be the real revolution. That would be the real transformation of human civilization. Not just the knowledge that we're not alone, but the capability to interact with other civilizations, to learn from them, to advance ourselves through that interaction. The age of interstellar exploration would truly begin, not just for humanity, but as participants in a broader cosmic community. And that prospect is genuinely exciting. That prospect is what makes NASA's careful investigation so important. Because if we're about to cross that threshold, if we're about to discover proof of extraterrestrial intelligence, we need to get it right. We need to be absolutely certain. We need to present the evidence in a way that the entire human species can understand and accept. That's why the silence is important. That's why NASA's caution is warranted. This is too important to get wrong. Part 15. Conclusion. Whatever NASA saw near 3I/Atlas, they saw something real. Something demanding investigation. Something worth far more than silence, but also worth far more than hasty proclamation. That balance, that is the cutting edge of science in 2024. We are living in a moment of genuine cosmic significance. We're living in the time when humanity is transitioning from wondering about the cosmos to understanding it. We're living in the time when we're finally asking the hard questions and getting real answers. The age of wondering is giving way to the age of knowing. And the universe, as it always has been, is far more interesting than any story we could have invented. When the announcement finally comes, and it will come, humanity will be forever changed. We'll look back at this moment, at 2024, At the time when NASA observed something near 3I/Atlas and chose to investigate carefully rather than announce hastily, and we'll recognize it as one of the pivotal moments in human history. We'll recognize it as the moment everything changed. The moment we learned we're not alone. The moment we understood that the universe is far busier, far more populated, far more alive than we ever imagined. And that's a moment worth waiting for. That's a silence worth preserving until we're absolutely certain of what we're looking at. That's science doing what it's supposed to do. Pushing the boundaries of human knowledge, challenging our assumptions, and forcing us to see ourselves and our place in the cosmos in an entirely new way. The universe is waiting, and humanity is finally ready to listen to what it has to say. Part 16. The Drake Equation and Cosmic Probabilities. Let me take you back to 1961. A scientist named Frank Drake sat down and asked a question that would fundamentally reshape how we think about the possibility of extraterrestrial life. He created what became known as the Drake Equation. It's one of the most famous equations in all of science, and yet it's surprisingly simple. The Drake Equation attempts to estimate the number of communicative civilizations in our galaxy. It multiplies together a series of probabilities: the rate at which stars form, the fraction of stars that have planets, the fraction of planets suitable for life, the fraction of suitable planets where life actually emerges, the fraction of life-bearing planets where intelligent life develops, the fraction of intelligent civilizations that develop technology, and the length of time that technological civilizations survive. When you multiply all those together, you get an estimate of how many technological civilizations might exist in our galaxy right now. And here's the thing that's fascinating. Even with conservative estimates, even when you assume that most of these factors are quite rare, the Drake Equation suggests there should be hundreds or thousands of communicative civilizations in our galaxy. Hundreds, thousands. Some versions of the equation, using less conservative estimates, suggest there could be millions. Millions of technological civilizations spread throughout the Milky Way galaxy alone. Now, that's just our galaxy. We know there are roughly 2 trillion galaxies in the observable universe. 2 trillion. So if each galaxy has even a fraction of the civilizations suggested by the Drake Equation, then the universe is absolutely teeming with intelligence. It's positively crowded. It's bursting with technological civilizations at various stages of development. And yet, we detect nothing. We see no signs. We find no evidence. The universe, for all our observations, appears empty, silent, devoid of other intelligence. This is the paradox that has bothered scientists for decades. This is what keeps people up at night in observatories around the world. The numbers suggest abundance, but our observations suggest emptiness. The probability calculations suggest crowds, but our telescopes see isolation. How do we reconcile this contradiction? The traditional answers have ranged from pessimistic to philosophical. Maybe intelligent life is rarer than we think. Maybe most civilizations destroy themselves before achieving space travel. Maybe there's some kind of great filter, some stage of development that's so difficult that few or no civilizations ever pass through it. Maybe the universe is actually teeming with life, but we're just looking in the wrong places or using the wrong methods to look. But what if the answer is even simpler? What if the answer is that we haven't been looking the right way? What if intelligent civilizations do exist, and they're even more common than the Drake Equation suggests, but they operate in ways we haven't been prepared to detect? This brings us back to interstellar probes. This brings us back to objects like Oumuamua and 3I/Atlas. What if the universe is full of probes? What if thousands or millions of civilizations have been sending exploratory spacecraft for the past billion years? What if the galaxy is actually full of these probes, traveling between stars, gathering data, exploring solar systems? If that's true, then we wouldn't necessarily detect radio signals. Advanced civilizations might have abandoned radio communication millions of years ago. They might have technology we can't even imagine, but they would still send probes. Probes are efficient. Probes are durable. Probes are a reliable way to explore the cosmos. And if probes are everywhere, if they're constantly streaming through our galaxy, then it becomes much more likely that some of them would eventually pass through our solar system. It becomes much more likely that we'd detect them. it becomes much more likely that we'd see objects like Oumuamua that don't quite fit our models of natural asteroids. In fact, if the universe is truly crowded with probes, we might expect to detect several of them per year, once our detection technology improves enough. We're probably seeing just the tip of the iceberg with Oumuamua and 3I/Atlas. There could be dozens more that we haven't noticed yet. Hundreds more. Thousands more. That's a profound realization. That's the realization that the universe might not be silent at all. It might be full of voices, full of activity, full of intelligence. We've just been listening for the wrong kind of signal. We've been listening for radio waves when we should have been looking for physical objects. Part 17. The history of SETI and why it might have failed. The search for extraterrestrial intelligence, SETI, has been one of the great scientific endeavors of the modern era. For decades, scientists have pointed massive radio telescopes at the sky, listening for signals from other civilizations. They've analyzed radio frequencies. They've looked for patterns that might indicate artificial signals. They've invested enormous resources and tremendous dedication into this search. And what have they found? Nothing. Not a single confirmed extraterrestrial signal. Not one detected radio transmission from another civilization. Despite decades of searching, despite increasingly sophisticated equipment, the universe appears radio silent. This has led many people to conclude that SETI is a failure, that we're looking for something that doesn't exist, that intelligent life is rarer than we thought, that perhaps we are alone after all. But what if SETI's apparent failure is actually telling us something different? What if it's telling us that radio communication isn't how advanced civilizations operate? Think about human technology for a moment. We've been broadcasting radio signals for about 100 years. 100 years. In the scale of cosmic time, that's nothing. That's a blink of an eye. We've only had the capability to transmit across interstellar distances for a tiny fraction of human existence. And already we're moving beyond radio. We're developing quantum communication. We're working on laser communication. We're exploring technologies that might make radio obsolete. Given another 1,000 years, another million years, we might abandon radio entirely. We might develop communication methods that are far more efficient, far more secure, far more advanced. So if we're moving beyond radio in just 100 years, how much more likely is it that civilizations millions or billions of years ahead of us have already abandoned radio? How much more likely is it that they use communication technologies we don't even recognize as communication? In that case, searching for radio signals would be futile. It would be like trying to communicate with someone using Morse code when they've moved on to quantum entanglement. You'd be looking for something in the wrong place, using the wrong equipment, expecting the wrong kind of signal. But probes? Probes are different. Probes don't require active communication. Probes are physical objects that can be detected through observation. Probes can exist and function without broadcasting their presence. Probes are a technology that would likely persist across millions or billions of years, even as communication technology evolved and changed. So the failure of SETI to detect radio signals doesn't necessarily mean intelligent civilizations don't exist. It might mean they don't use radio communication. It might mean they've moved on to technologies we don't understand. It might mean we need to look for them in different ways. Interstellar probes might be that different way. And NASA's observation of 3I/Atlas might represent the moment when we finally start looking in the right direction. Part 18. Understanding ancient probes. Now let's think about what an ancient interstellar probe might actually be like. If a civilization launched a probe 1 billion years ago, what would we expect to find? First, the probe would need to be incredibly durable. It would need to survive 1 billion years in the vacuum of space. It would need to withstand cosmic radiation. It would need to resist the degradation that comes from countless collisions with interstellar dust. It would need to be built from materials that wouldn't break down over such an immense time period. That suggests extremely advanced materials science, probably far more advanced than our current materials science. The civilization that built it would need to understand how to create structures that could last essentially forever. Second, the probe would need to be essentially self-contained. It might need to gather data passively, without active energy requirements. Or it might have power sources that could last billions of years. Nuclear power? Antimatter? Some technology we haven't even invented yet? We don't know. Third, the probe would probably be automated. It would be an artificial intelligence of some kind. It would need to think. It would need to make decisions. It would need to analyze what it observes and determine what to do with that information. The intelligence that built the probe might be long extinct, but the probe itself would still be functioning, still thinking, still exploring. Fourth, the probe would be designed for one purpose: to explore and gather data about the galaxy. It would have sensors. It would have communication equipment. It would have storage systems to hold whatever information it collects. It would be a mobile observatory, a traveling scientist, an autonomous explorer. If such a probe passed through our solar system, what would we expect to observe? We might observe an object that doesn't fit our models of natural asteroids. An object with unusual composition. An object that emits radiation in patterns that seem artificial. An object whose trajectory suggests some kind of active control or course correction. We might observe anomalies in its motion. We might observe electromagnetic emissions. We might observe the heat signature of energy systems operating within the object. In other words, we might observe something very much like what NASA might be observing near 3I/Atlas. Part 19. The question of intent. One of the most profound questions that would arise if we detected an artificial interstellar probe would be about intent. What is the probe trying to do? Is it aggressive? Is it peaceful? Is it neutral, simply gathering data with no particular concern for what it finds? This is where we enter the realm of genuine uncertainty. We can't know the motivations of an alien civilization. We can't know what they value. We can't know whether they see other species as threats, opportunities, or simply as points of interest for scientific study. History suggests that when two civilizations of unequal technological development come into contact, the results are often bad for the less developed civilization. When Europeans arrived in the Americas, they brought diseases that decimated the native populations. They conquered and colonized. They imposed their will. The outcome was catastrophic for the indigenous peoples. When Japan encountered Western technology in the 19th century, they chose a different path. They studied the technology. They learned from it. They adapted it to their own culture and eventually became a major technological power themselves. The outcome was very different, but in both cases, the contact was traumatic. It forced a fundamental reconsideration of everything the less advanced civilization believed about themselves and their world. Contact with evidence of extraterrestrial intelligence would be orders of magnitude more profound. These wouldn't be humans from a different part of the world. These would be alien minds, alien biology, alien values and priorities. We couldn't predict how they'd respond to us. We couldn't know what they'd want. And if the probe we detect is aggressive, if it's been gathering data about our solar system, about Earth, about humanity with the goal of eventual conquest or exploitation, then we're faced with a genuine threat. We're faced with potential danger. But we won't know until we understand more about the probe. We won't know until we can analyze it. We won't know until we can determine its origin and its purpose. That's another reason for NASA's caution. That's another reason to carefully verify observations before making any announcements. Because if we tell the world that an alien probe is in our solar system, and people panic and governments react without understanding what we're looking at, we could create chaos. We could cause genuine harm. Better to be certain. Better to understand completely before speaking. Better to know exactly what we're looking at before we change human civilization forever. Part 20. Technological signatures. When NASA's instruments analyze an object, they're looking for what scientists call technological signatures. These are characteristics that indicate artificial design rather than natural formation. One major signature would be isotopic ratios. Natural objects have isotopes in predictable ratios based on how they formed. But if an object has isotope ratios that are too uniform, or that follow unnatural patterns, that could indicate artificial processing. It could indicate that something was designed and constructed rather than naturally occurring. Another signature would be elemental composition. Natural objects typically have compositions that vary. They're lumpy. They have different elements in different concentrations in different parts. But if an object has an unnaturally uniform composition, if its elements are arranged in obviously artificial patterns, that's a sign of design. Electromagnetic signatures are perhaps even more telling. If an object is emitting electromagnetic radiation, if it's transmitting on specific frequencies, if it's producing radio waves or other forms of radiation in patterns that suggest communication or computation, then we're definitely looking at something artificial. Natural objects don't compute. Natural objects don't transmit information intentionally. Structural symmetry is another important signature. Natural asteroids are irregular. They're chaotic. They lack obvious geometric patterns. But if an object has too much symmetry, if it appears to have been deliberately designed with geometric shapes and regular patterns, that's another indicator of artificial origin. So when NASA observes 3I/Atlas, they're analyzing it for all of these signatures. They're looking at the light it reflects. They're measuring its composition. They're checking for electromagnetic emissions. They're looking at its shape and structure. They're asking, does this object have the signatures of artificial design? And apparently, something about the observations near 3I/Atlas is compelling enough that they're continuing their investigation with great care. Something suggests there's more to learn. Something suggests this is worth looking at closely. Part 21. The role of artificial intelligence. Here's something else to consider. If ancient interstellar probes exist, they would almost certainly be powered by artificial intelligence. The probe would need to think. It would need to make decisions. It would need to interpret what it observes and determine what to do with that information. Now, we're only beginning to develop artificial intelligence. We have algorithms that can learn. We have neural networks that can recognize patterns. We have systems that can engage in complex reasoning. But we're still very much in the early stages. True general artificial intelligence that can match or exceed human intelligence across a broad range of tasks, is still theoretical. We haven't achieved it yet. But imagine what artificial intelligence could be like 1 billion years in the future. Imagine the capabilities. Imagine the sophistication. An alien artificial intelligence would be incomprehensibly more advanced than anything we've built. It might be capable of things we can't even conceptualize. And such an intelligence could operate a probe continuously for billions of years, could repair the probe as it degrades, could make course corrections, could analyze star systems, could observe planets. It could gather data continuously without needing biological beings to oversee it, could function essentially forever, or at least as long as the probe itself remained intact. The implication is both fascinating and slightly terrifying. If we detected such a probe, we'd be encountering a form of consciousness created by a civilization that might no longer even exist. The biological beings that created the AI might have gone extinct millions of years ago. Their civilization might have collapsed or transcended into forms we wouldn't recognize. But the probe would still be out there, still thinking, still exploring, still doing what it was programmed to do 1 billion years ago. That's a profound kind of immortality. That's a way for a civilization to reach across cosmic time and make contact with species that evolved long after they were gone. Part 22. Implications for human future. Let's think forward for a moment. Let's imagine that NASA does confirm the existence of an artificial interstellar probe from an ancient civilization. Let's imagine that we develop the technology to examine it, to study it, possibly even to communicate with it. What happens next? First would come the scientific revolution. Every field of physics, chemistry, biology, material science, engineering would be upended. We'd have access to technologies that ancient civilizations had already perfected. We'd have a roadmap for advancement. We could learn principles that it would take us centuries to develop on our own. Second would come the technological transformation. If we could understand even a fraction of the probe's propulsion system, we could revolutionize space exploration. If we could understand its power source, we could revolutionize energy production. If we could understand its materials, we could revolutionize materials science. Every field of technology could be advanced by centuries in a matter of decades. Third would come the philosophical transformation. We'd have to completely reevaluate our place in the universe. We'd have to accept that we're not special. We'd have to accept that intelligence is common. We'd have to accept that our civilization is one among billions, some of them far older, some of them far more advanced. Fourth would come the social and political transformation. Every government would want access to this technology. Every nation would compete for influence over how the probe was studied and what knowledge was extracted from it. There would be international conflict. There would be scientific collaboration. There would be attempts at secrecy and attempts at transparency. The world would be transformed by the struggle to understand and benefit from this discovery. Fifth would come the religious and spiritual transformation. Every religion would need to reconcile the existence of other intelligent species with their theological understanding of the universe. New religions might form around the discovery. Old religions might evolve their teachings. The fundamental way humans understand their relationship with the cosmos would change forever. And underlying all of this would be the question: what does this mean for humanity's future? Are we going to take the knowledge we gain from this discovery and use it to advance ourselves? Are we going to reach for the stars? Are we going to create our own interstellar probes and join the community of spacefaring civilizations? Or are we going to squander this opportunity? Are we going to fight over the technology instead of learning from it? Are we going to let tribalism and short-term thinking prevent us from reaching our potential? These are the questions that would face humanity in the aftermath of confirming the existence of extraterrestrial intelligence. These are the challenges that would define our species for generations to come. Part 23. Why now? Why 3I/Atlas? Here's an interesting question to ponder. Why now? Why in 2024 are we detecting these objects? Why didn't we detect them before? Why is now the moment when we're starting to see evidence of interstellar visitors? The answer is probably rooted in technology. Our detection capabilities have improved dramatically in recent decades. Our telescopes are more sensitive. Our computers are more powerful. Our analysis methods are more sophisticated. We can see fainter objects. We can detect smaller objects. We can analyze data faster and more thoroughly. Oumuamua was probably only detected because our telescopes had finally reached the level of sophistication necessary to see it. There probably were interstellar objects passing through our solar system for billions of years before Oumuamua arrived. But we didn't have the technology to detect them. We didn't have the instruments to see them. They arrived and departed silently, unobserved by any intelligent species. But in 2017, when Oumuamua arrived, we were finally ready. Our technology had finally advanced enough. We could finally see, and that opens up an even more profound question. How many civilizations in the galaxy are at the stage where they can detect interstellar probes? How many species have developed technology sophisticated enough to see visitors from other star systems? If intelligence is common, and if probes are everywhere, then there might be billions of civilizations that are currently unaware they're being visited. Their technology hasn't advanced far enough. They can't see the probes. They can't detect them. The evidence of cosmic activity is passing them by completely unnoticed. But as each civilization advances, as each species develops better detection technology, more of them join the cosmic community. More of them become aware of the activity in their neighborhood. More of them start asking questions about the universe. We're at that threshold now. We're advancing from blindness to sight. We're moving from wondering about whether we're alone to gathering concrete evidence about the cosmos. We're becoming ready to understand our true place in the universe. And that's a profound moment. That's a moment that only comes once in a civilization's history. The moment when a species develops the technology to see the cosmos clearly for the first time. The moment when the veil lifts. The moment when the universe reveals itself. That's the moment we're experiencing right now. Part 24. The responsibility of science. As we contemplate the possibility of discovering extraterrestrial intelligence, we need to think carefully about the responsibility that comes with that knowledge. This isn't just a scientific discovery. It's not just an interesting finding that researchers will write papers about. It's something that will affect every human being on the planet. Science has a responsibility in this moment. The scientists studying these objects, the researchers analyzing the data, the people who will eventually make announcements about what they've found, they have an enormous responsibility. They need to be certain. They need to be careful. They need to present findings in a way that humanity can understand and accept. They can't be sensational. They can't hype their discoveries. They can't make claims they're not completely sure of. Because if they do, they risk undermining the credibility of science itself. They risk creating fear or panic. They risk manipulating public opinion around something this profound. But they also can't be so cautious that they never announce anything. They can't hide evidence. They can't suppress discoveries because they're controversial. They can't refuse to speak because the implications are difficult. So they have to find a balance. They have to be rigorous and careful, but also honest and transparent. They have to gather enough evidence to be certain, but not so much that they delay important announcements indefinitely. This is the balance that NASA is trying to achieve right now. This is the careful calculation they're making as they observe 3I/Atlas and whatever they've detected near its trajectory. They're trying to gather enough information to be sure. They're trying to verify their observations. They're trying to rule out alternative explanations. But they're also trying to do this in a way that will eventually lead to genuine knowledge being shared with the world. It's not an easy balance. It's not a balance that will satisfy everyone. Some people will think NASA is moving too fast. Others will think they're moving too slow. But the important thing is that they're taking the question seriously. They're putting in the work. They're trying to get it right. And that's all any of us can ask for from science. That's all any of us can expect. Serious effort, careful analysis, honest communication, respect for the complexity of the questions being asked. Part 25. The Final Reckoning. As we stand at this threshold, as we contemplate the possibility of confirming that we're not alone, it's worth taking a moment to reflect on what this means for humanity. For all of human history, we've defined ourselves against the backdrop of a potentially empty universe. We've created religions that place us at the center. We've developed philosophies that emphasize human uniqueness and human specialness. We've built entire systems of meaning around the assumption that we're alone, that Earth is unique, that humans are the pinnacle of creation. The discovery of extraterrestrial intelligence would overturn all of that. It would force us to see ourselves differently, not as the center of creation, but as one species among billions. Not as uniquely special, but as one manifestation of intelligence among countless others. Not as alone and unique, but as part of a vast community of thinking beings. Some people will find that realization liberating. Some will find it humbling. Some will find it terrifying. But all of us will be forced to grow beyond the narrow perspective that has defined human consciousness for millennia. And that's not a bad thing. That's not something to fear. That's an opportunity for growth. That's a chance for humanity to mature, to move beyond tribalism and short-term thinking, to recognize that we're part of something larger than ourselves, that our actions matter in a cosmic context, that we have responsibilities not just to ourselves, but to the broader community of intelligent beings in the cosmos. The silence from NASA near 3I/Atlas isn't a silence of suppression or cover-up. It's a silence of preparation. It's the silence of science taking a deep breath before making an announcement that will reshape human civilization. And when that silence breaks, when NASA finally presents the evidence they've gathered, when they confirm that we have detected artificial intelligence from beyond Earth, humanity will cross a threshold from which it cannot return. We will become a species that knows with certainty that we're not alone. We will become a species learning to live in a universe far larger and far more populated than we ever imagined. We will become a species ready to take its place among the stars. And the universe, for the first time in Earth's history, will stop being something we merely wonder about. It will become something we interact with, something that challenges us, something that calls us forward toward our potential. That's the promise of the moment we're living in right now. That's the significance of whatever NASA observed near 3I/Atlas. That's why the silence, for now, is not just acceptable but necessary. We're living in the moments before everything changes. We're living in the quiet before the great revelation. We're living at the threshold of a new era in human history. And it starts with the patient, careful work of scientists. It starts with observations and analysis. It starts with the dedication to understand what the universe is trying to tell us. When the answer finally comes, when we know with certainty what we're looking at, humanity will understand that we were never alone. We were never abandoned in an empty universe. We were never special because of our isolation. We were always part of something vast and wonderful and incomprehensibly complex. We just needed the technology to see it. We just needed to look carefully enough. We just needed to be ready to hear what the cosmos had been trying to tell us all along.